In this video, we're going to be taking a look at the interior angles of polygons. We're going to start by figuring out the sum of the interior angles of a polygon with n sides. In order to do this, we're going to use a couple polygons as examples. So we'll start with a triangle, and notice that I have the three interior angles marked. We want to know what those angles equal, which with a triangle, we should already know that triangle equals 180. We'll also look at a quadrilateral, and yeah, that one looks like a square. We will have a pentagon, and finally a hexagon. So our strategy here is to divide these shapes into a number of triangles, and then use that to find a pattern that will give us the formula for the sum of the interior angles of a polygon. By the way, if you want to try this on your own, you can go ahead and stop the video and try to figure out how you can divide these shapes into triangles that lead you to the formula. There's two main ways that we can derive this formula. They both come from dividing the shape into triangles. One way to do it is to start from one corner or one vertex and divide the shape into triangles. So with the quadrilateral, we end up with two triangles. And with the pentagon, if we divide it into triangles all from one vertex, we end up with three triangles. And in the hexagon, if we follow the same pattern, we end up with four triangles. So at this point, let's write down what we've found and see if that can lead to figuring out a pattern. So we want to come up with the number of sides, the number of triangles that we came up with, and finally, what is the sum of all the interior angles. So let's go ahead and list the number of sides for each shape. So our triangle obviously has 3 sides, our quadrilateral has 4, pentagon 5, and a hexagon has 6. Next up, how many triangles did we end up with? So the triangle is just one triangle, but the quadrilateral was split into 2 triangles, the pentagon was split into 3, and the hexagon into 4. So what you want to do is figure out what pattern do you notice between the number of sides and the number of triangles. So the sum of the interior angles, we know that the triangle has a sum of 180 degrees, and we probably knew before that a quadrilateral would have 360 because a square or rectangle has 4 90-degree angles. But notice that the two triangles inside the quadrilateral, their angles make up all of the interior angles of the quadrilateral. And same with our pentagon. So you can see that the pentagon, if we go 3 times 180, we end up with 540 degrees. And finally, the hexagon, if we go 4 times 180, we have 720 degrees. So the question is, how can we capture these 3 answers into a formula that follows the same pattern each time? So in other words, how can I take 3 sides and turn it into one triangle, 4 sides and turn it into 2 triangles? And the relationship is, if I start with 5, if I subtract 2, I end up with 3, and 6 minus 2 is 4. So what we've done here is for a triangle, we can think of it as 180 times 3 minus 2. Quadrilateral is 180 times 4 minus 2, and the pattern repeats. So now we can write in our formula, which would be 180 times n minus 2. And now we're going to revisit this one more time, but this time we're going to divide our polygon into triangles in a different way. This time we're going to actually start in the center of each shape and use the center to divide the shape into multiple triangles. So for our triangle, it'll look like this, and for our quadrilateral, it looks like that. The pentagon is there, and that's our hexagon. So this doesn't lead to as nice of a formula, but this strategy is what we'll use later on to find the area of these types of polygons. So let's take a look at what our table will look like this time. All right, we've already done the number of sides for each shape, And this time, when we look at the triangle, instead of it just being one triangle, we've turned our triangle into 3 triangles. So this time, the number of triangles matches the number of sides. So that would be the rest of our table. And then we already know the answer to what the sum is for all of these from our last one. So let's put that back in. So now the question is, how do we get to 180 for our triangle equals 180 when we have 3 sides and 3 triangles? We know each triangle is 180 degrees. So we start with 3 times 180. Well, that gives us 540, and we'd have to take away something to get to 180. When you look at the shape, do you notice the angles from the triangles that are not part of the interior angles of the original triangle? They are right in the middle. If we were to add up the angles of those 3 triangles, they would add up to 360 degrees because they form a full circle. So we have to subtract that 360 degrees from our 3 times 180. And so our pattern is we go the number of sides times 180, and then we subtract the 360 because you can notice that that circle of 360 degrees of angles is in the center of each polygon. So for our quadrilateral, we have 4 times 180 minus 360, and then the pattern follows for our pentagon and our hexagon. So notice that this time, we're taking the number of sides times 180 and then subtracting 360. To write this as a formula, we'll just switch it around a little bit at the start and write 180n minus 360. So in some ways, we found a different formula, but here's our original formula. Do you see what's happened here? If we took our original formula and just distribute, we end up with 180n minus 360. So you can use either one of these formulas, although I think the top one is much better because you can just take the number of sides, subtract 2 in your head, and then just multiply times 180. It's a little faster to get the answer that way. But showing you the second way, like I said, is important in the future when we try to find out the area of regular polygons. Speaking of regular polygons, that is where we are headed next. So what makes something a regular polygon? The first thing that we know about regular polygons is all sides are equal length. So we could mark our triangle with 3 equal sides. We could also mark our quadrilateral with 4 equal sides and finish up with the rest. In addition to the equal sides, all the angles are also equal. So we could go back. These angles kind of look like they're marked equal, but if we want to be perfectly clear in our communication, we could put these little single marks that show that all the angles are equal. So now we have clearly marked that all of these polygons that you see here are regular polygons. All the sides are equal length, and all the angles are equal. Since all of the angles of a regular polygon are equal, we can actually come up with a formula that will tell us one interior angle of a regular polygon with n sides. So let's start with our triangle. We know that the sum of its interior angles is 180, because triangle equals 180. And if we want to know what one of those angles is, we would divide by 3, because there's 3 angles. And that means that one interior angle of an equilateral triangle is 60 degrees. With a square, we can do the same idea. We would start with our 360, divide that by 4, and that would give us 90 degrees. And then we can use what we know about the pentagon and the hexagon to find out what one interior angle is when they are regular polygons. So let's take a look at how this would relate to a formula. So if we look at our triangle, we could start with what we use to get the sum of the interior angles, 180 times 3 minus 2, and then we divide by 3. And here's what we would do with the square, regular pentagon, and finally our regular hexagon. So hopefully by seeing all 4 of these at once, you can see what our formula is going to be for n sides. We're going 180 times n minus 2. That would give us the sum of all the interior angles, and then we just divide by n to get one of them. Let's go ahead and finish up with some practice problems. So you're going to be calculating the sum of the interior angles, and then you'll be calculating one interior angle for a regular polygon. And you've got your formulas to look at, so you're basically just putting in the number of sides for n and calculating your answer. By the way, an octagon, most of you know, is 8 sides, because you know that an octopus has 8 legs. A decagon, if you know how many years are in a decade, then you know how many sides a decagon has. By the way, there's probably some fancy name for a 20-sided shape, but a lot of these names are just mainly for people that are really into mathematical trivia. So when you don't know what the name of it is called, a 20-sided shape can simply be called a 20gon. Go ahead and try these problems, pause the video, and then hit play to check your answers. All right, so our first one, we're calculating the sum of the interior angles of an octagon. So we're going to put 8 in for n, and then we calculate this, 180 times 6, we get an answer of 1080 degrees. And here's your answer for a 20gon. When we're trying to get one interior angle, it only works for regular polygons, and we can plug 10 into our formula to find one interior angle of a decagon. And then I usually like to figure out what the top is. So we have 1440 divided by 10. So that means one angle is 144 degrees. And here's your answer for the 24gon. Our last two problems work backwards from the previous ones. Instead of giving you the number of sides, you're given the answer for the sum of the interior angles, and then you're given the answer for one interior angle of a regular polygon, and you're going to solve for the number of sides. We use the same formulas, so it's the same setup, but you're solving for n instead of the sum and the one interior angle. Go ahead and give it a try. So if you're stuck getting this set up, here's what we do for the first one. We just set up 180 times n minus 2, and we know that that equals 4680. And then to set up the second one, we have 180 times n minus 2 divided by n equals 170. Now let's take a look at how you would solve these. On the left side, you could distribute the 180, but it's going to be easier if you just divide both sides by 180. This leaves you with n minus 2 equals 26, which means n is 28. So that would be the number of sides we have when the sum of the interior angles is 4,680 degrees. On the right side, we want to get rid of the fraction part. So the opposite of dividing by n would be multiply by n, and we'll do that to both sides. So on the left side, the n's cancel out, and I'm going to go ahead and distribute my 180 times n minus 2, and on the right side I have 170n. Now I'm going to go ahead and do two steps in one. I'm going to subtract 170n from both sides, and I'm going to add the 360 so it ends up on the right side. Final step, divide by 10, and we get n equals 36. So if the interior angle of a regular polygon is 170 degrees, that means we have 36 sides. And that'll wrap up our video on interior angles of polygons.